I'm Steve Lee. I'm Curator of Planetary Science here at the Denver Museum of Nature and Science. My role here is to bring planetary science to our museum visitors. A lot of the space exploration that's going on currently is exploring the solar system, from Mercury all the way out to Pluto, and comets, asteroids, everything in between. So it's really important that our visitors get to understand this exploration that's going on, and that's my job, is to try and interpret that and translate the major findings that are happening daily in space exploration, so that our visitors can understand and be part of the exploration process. My background is I'm a Mars scientist, so I've been studying the planet Mars using spacecraft since the mid-1970s. So any Mars mission is sort of the apple of my eye. The mission that I've been working on for about the last 15 years is the Mars Reconnaissance Orbiter.
Engine ignition and liftoff of the Atlas V rocket carrying the Mars Reconnaissance Orbiter for NASA.
MRO launched in 2005. It arrived at Mars in 2006. It's been returning data ever since. And I was part of a team that built two of the camera systems that are on board MRO. And so every day I get new data back from Mars, new images. I can look at it in the morning and say, this is what Mars looked like 12 hours ago. That's sort of what my research life is all about, is looking at how Mars changes, how the weather affects the surface, how this changes over time. The Mars Reconnaissance Orbiter was built in Denver by Lockheed Martin. Doesn't do us any good sitting here. It has to be at Mars. And in order to do that, we have to get it off the surface of the Earth. We have to propel it at something like 25,000 miles an hour in the direction of Mars. It has to be in exactly the right spot at the right time to intercept Mars on the other end. And so that's what the rocket does. That gives us our ride to Mars. The rocket is hundreds of thousands of pieces that have to work together. So there's an enormous amount of power and energy and vibration and mechanical complexity that all has to work together to get this from 0 miles per hour up to an escape from planet Earth. And that all has to work essentially perfectly. So that's what United Launch Alliance brings to the table. They have this essentially an assembly line in Decatur, Alabama, but it's dedicated to building these very complicated rockets. And they turn them out at the rate of about 10 a year, sometimes a few more, but their entire operation is geared around the utmost in cleanliness and the utmost precision, that everything has to be perfect. They're very good at what they do. Their rockets work. Their rockets give us the best assurance we have of getting these very, very valuable and very, very expensive payloads off the ground. There certainly have been, over the years, many rocket failures where billion-dollar spacecraft end up crashing to the Earth. We haven't had that type of experience with United Launch Alliance, so they really are the cream of the crop. They know what they're doing, and they're certainly the preferred ride into space. The Orion spacecraft is the next generation of human spacecraft for the United States. It's intended to be an exploration vehicle where we'll be able to send astronauts beyond Earth orbit. So instead of going just to and from the space station, we'll be able to send them to the moon, to asteroids, eventually to Mars. And we're just now at the point of starting to test the Orion system. To lift this very heavy spacecraft, they needed a much, much larger rocket than like what we would use to send MRO to Mars. And so what was chosen was called the Delta IV Heavy, which is, the Delta IV is already a large rocket. They bolt 3 of those together. And it's currently the largest rocket in the world. And it needed all of that power in order to get Orion to where it needed to go. And it's a very, very spectacular rocket to see, because it's sort of 3 times everything. Very, very large, very loud, very bright. It was just a very spectacular launch, and that is one that I was lucky enough to be about 3 miles away to see. I've been to, gosh, probably 30 launches over my career, about 9 shuttle launches when they were still operating, but lots of unmanned launches, and it's always an absolute thrill. It's even more so if something that you actually worked on, like Mars Reconnaissance Orbiter, is on the nose of the rocket. You get very nervous because you know that it's a very difficult thing to do, but it's also just absolutely stunning to see the rocket light up and see this 20-story building just clawing its way into the sky, and it's going faster and faster. And you know, after about 15 seconds of doing this in silence, because you're so far away from the launch site, then the noise hits you and it just washes over you. I mean, literally it brings tears to your eyes. There's so much emotion. This is your creation and it's being sent to another planet. So there's a lot of pride, there's a lot of anticipation for the work it's going to do once it gets to Mars. In my case, certainly brings tears to my eyes. The location we're coming to you from is called the United Launch Alliance Assembly Facility. It's in Decatur, Alabama, which is in northern Alabama. It's where they assemble both the Atlas and the Delta rockets. They bring in all of the pieces from the various vendors around the country, and they put them together, and they get them ready to put on a barge and ship to either Kennedy Space Center in Florida or Cape Canaveral Air Force Station in Florida, or Vandenberg Air Force Base in California. And those are the 2 locations that both of these rockets can be launched from. So from start to finish, you know, they put it together, they make sure that everything is ready to fly, then they send it off to the launch site. The final preparations are done at the launch site. They attach the payload and roll it up to the pad and send it on its way. Craig Langford is the vice president at United Launch Alliance in charge of this assembly facility at Decatur. And so he'll be telling us how this facility works, the details of what they do, and what to expect when you're joining us from Decatur.
I'm Craig Langford. I'm the Vice President of Production Operations for United Launch Alliance, also known as ULA. We're America's ride to space, and what that means is we build these huge rockets. They don't look so huge here on the table, but in real life, they're over 200 feet tall. So I got into rockets when I was very young. I was actually, when I was in 3rd and 4th grade, I was at Cape Canaveral and lived there and saw the Apollo launches to the moon. And I was hooked at that point, but didn't get the opportunity until much later in life when I graduated from college to work and actually build and launch rockets. It was amazing to watch those huge rockets lift off, knowing that they were going to the moon. It was just a really exciting time to live there. So the work that we do at ULA is we build rockets. Our factory is about 1.6 million square feet. If you can imagine that, we get aluminum in the north end of a building. It's a sheet of aluminum about the size of a large living room and about 2 inches thick. We take that and then we use computerized mills to mill out the tank skin so it's much, much lighter, but still retains most of its strength. I can show you an example of this over here. This is a small piece of what the tank looks like from the inside. So if you're actually inside the fuel tank of one of these rockets, this is what you'd see. And on the outside, you'd see the smooth surface. This is a very, very light piece of aluminum and weight is very important for rockets. You want to make sure that you have the lightest rocket that you possibly can so you can launch the heaviest satellite that you possibly can. We currently have 3 rockets that are in production, 2 of the ones that I have here, and we also have the Delta II, which is a smaller rocket that we have 2 left to launch. But this is kind of the workhorse of our fleet. This is the Atlas V 401 configuration. And the reason we call it a 401 is because it has a 4-meter payload fairing. This is where the satellite actually sits for the ride to space inside here. It has 0 solids, as you can see on the outside, 0 solid rockets strapped on, so it's only liquid fuel. And then it has 1 upper stage engine, so that's how we get to the 401 configuration. This is the Delta IV. This is a larger rocket. It is a 5-meter version, as you can see, and this is our medium plus 5-4. So we have a 5-meter payload fairing and 4 solids that are on the bottom of the rocket. The purpose of the solids, you might wonder why some rockets have solids, some rockets don't have solids. If you have a very, very heavy payload and you need to get it off the ground, you need to make sure that you have more thrust initially, or more fire coming out of the bottom than the whole rocket weighs. So you have to have more push going down than you have weight holding you down. But all of these rockets are 2 stages. So we have the first stage, or the booster. It separates right here at this split line. Then the upper stage ignites, and it takes the satellite all the way into orbit. And it may ignite many times, depending on the type of orbit that we need the satellite to be in. The reason we do that is because there's many different types of satellites out there, from very light satellites that want to go in low Earth orbit to very heavy satellites that may want to go all the way to Pluto or to Mars or something like that. So with our new rocket, the Vulcan, we're going to be doing a lot of things differently. And we're doing them differently for a reason: to make the rocket more cost effective. Rockets are expensive. We also want to make it higher performing. So another thing that's different about the new Vulcan rocket is the engine. We're going to be putting an all-new engine on there. It's an engine that burns liquefied natural gas and liquid oxygen, which is different than our existing rockets. Our existing rockets burn liquid hydrogen and liquid oxygen for the Delta, and RP1, which is Rocket Propellant 1, or fancy name for refined kerosene, on the Atlas. But for many reasons, liquefied natural gas is a better fuel for our new rocket. It's going to aid us in reusability, which is one of the really cool things that we're looking for the Vulcan to do. We actually have plans to eject the engine section. After it's done firing and separating the second stage, this whole engine section will come off. It will have an inflatable heat shield. A parafoil parachute will then come out, and that will be recovered by a helicopter so that we can reuse the engine. The engine is a huge part of the cost of the rocket, because you build a rocket around an engine. You don't add an engine onto a rocket. All a rocket really is a big fuel tank and a big oxygen tank connected to an engine. Now these are 2 of our new rocket. This is currently in development, and one of the most exciting things that I get to do is develop a new rocket. It takes about 6 years, maybe 5 to 6 years to develop a new rocket, and we're right in the middle of that right now. This is the largest of our new Vulcan rockets. On this version, the upper stage is actually hidden inside the 5-meter payload fairing, and you can't see it until after the payload fairing separates. So the payload fairing separates when we get out of the atmosphere. There's quite a few people that want to use these rockets. Give you an idea of just some of the satellites that we put into space and what they do. If you've ever used your cell phone to navigate from your house to a restaurant or to a grocery store, we enabled that by putting up the Global Positioning System constellation. Every one of those satellites was launched by United Launch Alliance or our predecessor companies.
3, 2, 1. We have ignition. and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
We've launched a lot of missions for NASA. Some of our NASA missions in 2006, we launched a mission called Pluto New Horizons that just got to Pluto in July of this year. That's how long it takes to get some of the distances in space. It was the fastest object that ever left the Earth when we launched it in 2006. We used our biggest rocket to get it out of the gravity well. We're always fighting gravity, trying to get our payloads up into orbit where our customer needs them. We've also launched a lot of missions to Mars. We've launched missions to Saturn, we've launched missions to Jupiter, we've launched missions to every planet in the solar system. Well, I always tell people, there are two things that give me goosebumps. One is hearing the national anthem, and one is watching a rocket launch. It just never fails. It's the best experience that somebody that is an engineer in this industry can ever have. You're making these rockets in Decatur, Alabama, but yet you have to launch them from Cape Canaveral, or you have to launch them from Vandenberg Air Force Base in California. How the heck do you get something that big from Decatur, Alabama to Cape Canaveral in Florida? Well, we're not located in Decatur by accident. The reason we're there is because we're on the Tennessee River, and we have a really big ship called the Mariner. It's big enough that we can load up to 3 rockets into the ship. The ship then goes down the Tennessee River to the Mississippi River, out of the Mississippi Delta into the Gulf of Mexico, around the tip of Florida, and docks at Cape Canaveral, where we offload it and stand it up and put it on the launch pad. Putting a rocket together, just building a rocket, is really, really hard. And we have about 800 people that are involved in building these rockets. Getting it to the launch site, that's really hard too. The rockets are big, so you've got to figure out a way to get them there so that you can launch them at the launch site. And then getting them to the right place in space. Launching a rocket and getting it to on its own. So once we launch it, nobody controls it. It controls itself. And we've already pre-programmed the guidance system to get it to the exact point in space that our customer needs that satellite to be. And we've launched astronauts in the far past on our Atlas launch vehicle, the earlier version of the Atlas. A lot of people don't know this, but in the early 60s, we launched the first American into orbit. That was John Glenn, and that was on an Atlas rocket. And we're going to return to that heritage in 2018. We're actually flying to the space station with some cargo toward the end of 2015 and 2016, and then we'll be taking astronauts into space starting in 2018. One of the things that we've done recently for NASA is that we launched the Orion space capsule into space in December of 2014. It was launched on our biggest rocket, and this doesn't really give you the appreciation for it because our biggest rocket is America's biggest rocket. It's the Delta IV Heavy, and if you can imagine 3 of these first stages strapped side by side, almost 50 feet wide and 240 feet tall. It is a beast.
And liftoff at dawn, the dawn of Orion and a new era of American space exploration.
Is the size of a school bus and weighs a lot more than a school bus. And we'll use that rocket that we select to get the customer into whatever orbit they want. I love my job. I mean, what better job can there be to be able to tell people I actually am a rocket scientist and I work with rocket scientists. It's just the best job I could have ever imagined. And I think the possibilities for the future and the future generation of rocket scientists are even much more exciting than what I've been able to enjoy. The things that we're doing in space now, we can't even imagine. There's several folks that are working on hotels in space. Maybe that'll be the place that we take our summer vacation. I don't know, but I know that the next generation's the people that are going to get us there.